Today's lesson is on isosceles triangles and equilateral triangles. So my learning goal for today is I can solve for sides and angles of equilateral and isosceles triangles by applying congruent and proportional relationships. So let's start out by working with a triangle and talking about some sides and angles. So let's list our first, middle, and last name. So my first name is Kathy. So I'm going to use the K. My middle name is Mary. And my last name is Stout. So my initials I'm going to use are KMS. Okay. So triangle KMS. Okay, we're going to talk about sides and angles. So the sides are lowercase and angles are uppercase. So my side is going to be a lowercase k, and my angle is going to be an uppercase k. So here's my vertex. Here's my angle. So across from my angle is my side k. Okay, so for side M and vertex M, so my side is across from my angle. I guess I'm going to put this in here too. Here, so this. Let's go back and put that here. So here's my angle. Here's my side. And for my third side, S and S. So S, and the side across from S is side S. Okay, so sides are lowercase, angles are uppercase. All right, so let's go talk about an isosceles triangle, and let's name some parts. Isosceles triangles have special parts for their names. They're very special triangles. So I have some things that start out with called a vertex angle. So this angle right here is called the vertex angle. And I have one of these. And I have a base angle. I have two of these. So I got a base angle here and here, and these would be equal. I also have a base. Here's a base. So between the two base angles, I have a base, and I have one of these. I also have two legs. So I have two base angles, two legs, one vertex angle, and one base. Okay, so let's start out with if we have two theorems here. I have the base angle theorems and the converse of the base angle theorems. So the base angle theorem says if two sides of a triangle are congruent, then the angles opposite of them are congruent. And the converse says if two angles of a triangle are congruent, then the sides opposite them are congruent. So we're talking about these legs and the base angles. So I'm talking about if these angles and sides are equal. So my base angles and my base and my legs go together. All right, so let's do a couple problems. Let's try a couple here. So find the measure of angle F. So this is the one I'm trying to find here. Find the measure of angle F. So looking at my diagram, I see that I have two sides that are congruent. So when two sides are congruent, then that means the angles opposite them are congruent. So this angle is congruent with this angle. So these would be my base angles. And then I also know that when I add all three angles together, they total 180 degrees from the Triangle Sum Theorem. So I'm going to say x plus 22 equals 180. So I'm going to combine like terms. So 2x plus 22 equals 180. I'm going to add the inverse, which is negative 22. So 2x equals 158. I'm going to divide by the coefficient next to the variable. So x equals 79 degrees. So this is the measure of angle F. Equals 79 degrees. Okay, let's try another one. Find the measure of angle G. So if I want to find the measure of angle G, I need to know what x is. So I need to set up an equation and solve for x first. Okay, so I have two sides that are equal. So the two sides are equal. I know that angles across from them are equal. So I know this angle is equal to this angle. So I can set up my equation to say x plus 44, so angle G is equal to angle J equals 3x. So angle G is congruent to angle J. So I'm going to add the inverse, which is minus x. 44 equals 2x. I'm going to divide by the coefficient next to the variable, which is 2. 2 divided by 2 is 1. So 22 equals x. So now I can go substitute this in. So 22 plus 44 is 66 degrees. Make sure we use a degree symbol because we're talking about an angle. Okay, so next I have a corollary to the base angles theorem, and a corollary means it's related. So this says if a triangle is equilateral, then it is equiangular. So equi again means equal, angular angles, equal angles. Equilateral, so equal sides. So if I have 3 equal sides, then I also have 3 equal angles. And the converse is if my triangle is equiangular, then it is equilateral. Okay, so let's do some problems. Find the value of x. So I'm looking at the marks. So the marks tell me I have 3 equal sides. So that means I have 3 equal angles. And we said yesterday in our previous lesson, if I'm equiangular, then I know these angles are all 60 degrees. So I can set up my equation to say that 2x plus 32 equals 60. I'm going to add the inverse, which is negative 32. So 2x equals 28. I'm going to divide by the coefficient next to the variable. So x equals 14. And this time it's just asking me to solve for x, so I can stop here. So make sure I answer the question. If I need to substitute, let's make sure we can do that. All right, last example. Find the value of x and y. Okay, we have a lot going on here. So I'm going to start with the left triangle. So I see that I have 3 equal sides. So that means I also have, we have 3 equal angles. So that also means I have 3 equal sides. So if this side is 4 and this side is y, I know y equals 4. So I know this side is also 4. Next, I see that I have these 2 angles are congruent. So if these 2 angles are congruent, that means the sides opposite them are also congruent. So I can set up an equation to say x plus 1 equals 4. So I'm going to add the inverse. So I get x equals 3. Okay, that's it.